Okay, everyone. This next section is on SI units and the conversion method. SI units, I know you've all encountered these before, so I'll go over them pretty quick. Conversion method. This is when you're changing meters to centimeters, or centimeters to gigameters, or whatever, meters per second to centimeters per minute or something like that. Okay, and you can do, using this method, you can change whatever you want, and it'll come very handy in all your other science courses, like especially physics. So this one here, so we're going to go over these mass. International System, or SI, System International, is the system measurement used in scientific community and all over the world. SI prefixes make it very convenient to convert from one value to another. These conversions are necessary to follow certainty and precision rules and the rule of 1,000. So base units of the SI system, it is a basic unit of measurement. All other units are multiples of the base units. All right, so our base units, right, for mass, we use gram, right? Symbol for gram is a G. Length, we're going to use meter. And that's an M. So temperature is Kelvin. That's a K. Volume is liter. We got an L there. Mole, this is going to be in our next unit. Mole is amount of pure substance. Maybe you haven't come across this one before. And the symbol for that is MOL. Time is in seconds or second, and this symbol is S. Energy is a joule, and the symbol is J. All right, so those are our SI units, right? We should know all these ones. I'm sure you know probably all of them except for maybe mole and possibly joule. All right, so let's go on the next one. So if you had a prefix to unit, it allows us to demonstrate very large or very small measurement, right? So we have all these ones. So these 6 are ones that we need to memorize. All right, and the values always compared to the base unit. So when we're doing these calculations, always convert back to the base unit. So basically, a giga, right? You've heard of gigabytes, of course. Symbol is a G, and it's 10 to the 9. So 1 gigameter is 10 to the 9 meters, right? So I can write it both ways. So 10 to the 9 meters is equal to 1 gigameter. All right, our conversion factor, we'll put it like this. So 10 to the 9 meters over 1 gigameter, right? So in these conversion factors, the top always equals the bottom, and the bottom always equals the top. So the one with the power, this is going to be your base unit, always, right? So mega, like megabyte, right? 10 to the 6. So 10 to the 6, we'll keep going with meters, right? So our conversion factor, 10 to the 6 meters equals 1 megameter, right? And the same thing, the opposite is also true, the upside down. So 1 megameter equals 10 to the 6 meters. All right, kilo, right? Kilogram. We'll go for grams for this one, right? So 1 kilogram is 10 to 3 grams, right? It's 1,000 grams in a kilogram. So I'll put it over here. Running out of room. Maybe you can do it better. So we got 10 to the 3 grams is 1 kilogram. And the opposite also true. 1 kilogram equals 10 to the 3 grams. All right, centi. So now we're getting less than 1 meter. So this is going the opposite way. So 10 to the minus 2. So 10 to the minus 2 meters is 1 centimeter. And like you also know that there's 100 centimeters in 1 meter, right? So both are true. I find doing it this way, students make less mistakes. So I'll put that one down here. So 1 centimeter is equal to 10 to the minus 2 meters, right? Notice how it's always the one with the power is with your base unit. So you're just converting it back to your base unit. If you remember all these conversion factors, then you're good to go. So the other way, right, 10 to the minus 2 meters is equal to 1 centimeter. Milligram, millimeter, millisecond, right? So 10 to the minus 3 seconds, I'll put this one down here, right? 10 to the minus 3 seconds is equal to 1 millisecond, right? Also, 1 millisecond is equal to 10 to the minus 3 seconds. All right, so this is just your conversion factor. Top always equals bottom, bottom always equals the top. You get these memorized. This is like your ABCs of conversion factors. All right, micro. All right, that's as small as we're going to go. That's usually the smallest you go in chemistry. Sometimes you can go lower, like nano and pico. But all I want you guys to memorize is these six things, and you're good to go. So same thing, 1 micro. It's like a U with its tongue hanging out. It's called a mu, the symbol for that one. So 1 micrometer equals 10 to the minus 6 meters, right? So I'm using meters a lot, or seconds, or grams, but because that's what we use most of the time in chemistry. But you can use any of these. Any of these unit symbols can be interchanged with that. So, and that's the same as 10 to the minus 6 meters equals 1 micrometer. All right, so these are your conversion factors. We'll do a little activity in class and try to get you to work on memorizing these. But once you memorize them, you're good to go. All right, so this is going to bring us to our conversion factor. Probably one of the most important things you're going to do as far as your math toolkit. Sig figs and conversion factors, they're going to come up on like virtually 90% of your questions, right? So if you're good with your conversion factors, do it like this, and you'll be good to go moving forward, not only in chemistry, physics, and later on. All right, so this method can be used to convert prefixes with the SI system, and will come in handy when doing conversion in the mole unit, which we're going to talk about next. This method is one that will help you with any conversions, chemistry, math, physics, and yes, in university too. So get it down now, and your life will be much easier later on the course. Ask yourself a few questions. So when you look at the questions, what are you being asked for? What is the given information, and what is the conversion factor? If you have these 3 things, then you can do them. So these ones we're doing here, they're just a couple steps, just to find the answer. But sometimes you're going to have ones in stoichiometry which are like 7 steps long. But as long as you keep with this basic premise, you'll be good to go. So let's do this one. Okay, we'll look at it. How many grams are in 56.7 kilograms? All right, so you look at number of unit that you have. So this is what we have, are 56.7 kilograms. All right, so I write that down, 56.7, right? That's what we have, right? You have 56.7 kilograms. Okay, write down everything. And we're going to multiply. All right, and we're just looking for grams. So we want a conversion factor for kilograms. So how many grams in a kilogram? Right, so 10 to 3 grams in 1 kilogram. So your conversion factors, try to memorize your conversion factors as well as soon as possible. So what do you want? You want grams. So our conversion factor is on top. So I'll just write this over here. Our conversion factor, 1 kilogram is equal to 10 to the 3 grams, or 10 to the 3 grams is equal to 1 kilogram. All right, so that's our conversion factor. We want to use one of these to get what we want. So the unit that you want is on top, the unit you have is on the bottom. So we want grams, so this is the one we're going to use. We're going to use the 10 to the 3 grams over 1 kilogram. So that's a conversion factor. So 10 to the 3 grams over 1 kilogram. All right, and so then it's just a matter of plugging into your calculator. So I'll just do it over here. So oops, 56.7 times 10 to the power of 3. All right, and that's it. So, and this one here, what is it? 56,700. Turn the scientific notation. We jump 1, 2, 3, 4. Right. So it's and our sig figs. 3 sig figs in the question. These have infinite number of sig figs, so 3 sig figs in the answer. So it's going to be 5.67 times 10 to the 4 grams. All right, so we notice when we're doing this, we know we have a conversion factor when they're cancel properly. So we see kilograms on the top, kilograms on the bottom cancel. So anything that's on the top and anything's on the bottom will cancel. And then we're left with grams on our own. So go through this mental checklist after you do the question. So we got kilograms cancel, and we got grams on top, grams that we want. All right, we're changing from kilograms, which are larger than grams, so we should have a larger number. So try to think of it logically when you do it as well. All right, let's look at the next one. So how many milliliters, so that's what we're looking for, are in 1.2 times 10 to the 6 liters. All right, so unit that you have, write it down. 1.2 times 10 to the 6 liters. Multiply. Our conversion factor, milli, right? That's 10 to the minus 3 liters is in 1 milliliter, right? So I'm going to write my conversion factor. So I want milliliters, right? You want milliliters, so you have it on top. So 1 milliliter is equal to 10 to the minus 3 liters. All right. So now all we do, I'm going to put in brackets 1.2 and my exponent times 10 to the 6. And then you're just going to divide by. It's on the bottom, so I'll divide by. So we're going to go divided by 10 to the power negative 3. All right, 10 to the power negative 3, enter. All right, so it's a big number. We're jumping 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so 2 sig figs in the question, 2 sig figs in the answer. So we're going to get 1.2 times 10 to the 9 milliliters. Okay, check it cancels, the liters cancel. We have milliliters, right? The conversion factor is right, so we got the correct answer. Okay, you guys try the next two and see how you do. We'll just pause it and then come back. Okay, so I'll do this one. How many megagrams are in 8.9 grams? So write down what you have. 8.9 grams. Mega is 10 to the 6. So we want megagrams. So megagrams are on top. 1 megagram equals 10 to the 6 grams. Okay, and so equals 8.9 divided by 10 to the 6. It's going to be 8.9 times 10 to the minus 6, all right? Megagrams. All right, so we can see it. Grams cancel, megagrams at the top, good to go. Next one, how many meters in 1.78 times 10 to the negative 5 kilometers? So kilometers and meters, that's where we're going. So what we have, 1.78 times 10 to the negative 5 kilometers. And then we're going to go 10 to the 3 meters over 1 kilometer. All right, put in our calculator. We got 1.78 times 10 to the negative 2. All right, check it. All right, kilometers cancel. We have meters on top. That's what we're looking for. And see our conversion factors. They're correct as well. All right, so that's whole numbers. Let's go on to the next ones. Okay, so this next one, they're a little bit more difficult. Both have prefixes. So we're going to put one more step in there. So how many microliters are there in 5.0 kiloliters? All right, so we look at this one. So what we have, 5.0 kiloliters. All right, so I want to go kiloliters to meters, meters to micrometers. All right, so I'm always going back to my base unit. So we got 10 to the 3. So we're going to go from kiloliters to liters. So 10 to the 3 liters is 1 kiloliter, right? So kiloliters are going to cancel. And then I want to go to micrometers, then meters to micrometers. So 1 micrometer is 10 to the minus 6 liters. All right, put my calculator, 2 sig figs in the question, 2 sig figs in the answer. We got 5.0 times 10 to the 9 microliters. Okay, next one. How many megameters are there in 0.006 centimeters? So I'm going to do this. I'm going to change it to scientific notation right away just to make it easier. So I'm going to jump. So it's going to be 6 point, just 6 times 10 to the negative 4. All right, we only got 1 sig fig on that one, centimeters. All right, so I want to go centimeters to meters, meters to megameters. So centimeters to meters is 10 to the negative 2. So 1 centimeter is 10 to the minus 2 meters. Okay, and now to megameters. 1 megameter on top, that's what I want, is 10 to the 6 meters. All right, put in my calculator. I can do it just mentally. It's not too hard. And that's going to be 6 times 10 to the negative 12 megameters. Right, so I'm just doing power laws. Minus 4, you add it on the top, you subtract on the bottom. So minus 4 and plus minus 2 is minus 6. Minus 6 is negative 12. So I just did my power laws, if you remember that from your Math 10 course. All right, next one. All right, you guys can try these ones. I'll come back and help you. Okay, so how many milligrams are there in 0.00032? 0.0032 gigagrams. So this one here, we got 3.2. I'm going to change it to scientific notation. Jump 1, 2, 3, 4, 5. All right, so 5, so 3.2 times 10 to the negative 5 gigagrams. All right, and then we got 10 to the 9 grams over 1 gigagram. All right, then we're going to go from grams to milligrams. So 1 milligram is 10 to the minus 3 grams. All right, so 5 and 9 is 4. Minus negative 3 is 7, so we got 3.2 times 10 to the 7 milligrams. All right, I can use my calculator too, but I'm just doing power laws because it's fairly straightforward. All right, this next one here, how many seconds are there in this year? So 2020 is a leap year. So we're going to go from days to hours, hours to minutes, minutes to seconds. So just start off 366 days times, so we got 24 hours in 1 day times 60 minutes in 1 hour times 60 seconds in 1 minute. All right, so just multiply them all together. So it's 366, 24 times 60 times 60. And it's like I got 31622 All right, so that's how many seconds we have in 1 year. All right, so don't waste a single second, right? All right, next one. So now these ones, we're going to change the bottom unit. So we have kilograms per milliliter and then kilograms per liter. So the conversion factor is the same, just we want to orientate it so that they cancel it out. So same as before, you start at what you have. So 4.0 kilograms per liter. All right, and I want to go kilograms to milliliter. So I want to make it so the milliliters, the liters are going to cancel. So so we got times, so 1 liter is 10 to the minus 3 milliliters. All right, so 4.0 minus negative divided by 10 to the minus 3. And this is going to be equal to 4.0 times 10 to the 3. Great. Liters cancel, and then we got kilograms per milliliter. And that's what we want. Okay, next one. We got 0.006 grams per microliter, and we're going from grams to liter. So I'm going to do this. So 6 times 10 to the minus 3 grams per microliter. All right, and grams per liter. So I'm going to get the microliters to cancel. So 1 microliter is 10 to the minus 6 liters. All right, and then that's just negative 3 minus negative 6 is 6 times 10 to the 3 grams per liter. All right, last one. We're going to change both of them, so a little bit more difficult. So this is going to be 3 times 10 to the negative 3 micrograms per second. All right, so I want to change seconds to minutes, and then micrograms to grams, and then grams to milligrams. So I'm going to do the first one. So seconds to minutes, so go at 60 seconds in 1 minute. All right, then multiply this. So our micrograms to grams. So 1 microgram is on the bottom, 10 to the minus 6 grams. And then to milligram, and then we want milligrams on the top. So 1 milligram over 10 to the minus 3 grams. All right, and then we just multiply it out. We got 3 times 10 to the negative 3 times 60 times 10 to the power negative 6 divided by 10 to the power negative 3. All right, and I get 1.8 times 10 to negative 4. And my units, milligrams per minute. All right, so there's your assignment number 5. Let me know if you have any questions in class, and we can and post your assignment to the Google Classroom.